Hello everyone, welcome to Learn Overflow. In this video, we'll look into this LeetCode problem that is a unique path. We'll understand what this question is asking us to do and how we can actually find a solution to this kind of problem. We'll understand this taking small examples and then we'll go ahead and find a solution to the bigger problem. Okay, we'll break into a smaller problem and further find a solution to the bigger problems. Okay, so this is a medium level problem and we'll understand this one by one. So before beginning this video, let's make sure to subscribe to this channel for regular LeetCode videos like this. So what the question is telling us, the question says us that there is a robot on an M cross N grid. So there's a grid of M cross N and there's a robot standing on a M cross N grid. The robot is initially located on the top left corner. So that's the top left corner over here. Fine. That's the grid 00. It mentions to us. Okay. Now also it further says that the robot tries to move to the bottom right corner. So that's the bottom right corner we have over here. Fine. Now from the bottom right corner, there's a grid of m minus 1 n minus 1. It mentions to us. Okay, the further it says the robot can move either down or right. So this is important for us. The robot cannot move left or cannot move up. So robot can have only two directions to move. That's the either moving down, like either it can move down or it can move right. Fine, like at any position it can move down or it can move right. If right is if down or right is a valid position, we need to know that. Okay, fine. Now it says further that given two integers m and n, so there's two integer m and n are given to us and we need to return the m and n, like this is m and n, so m and n being the like m cross n being the grid. So that's what we need to think of it like that. Fine. So we need to return the number of possible unique paths. We need to return the how many paths, like possible paths that the robot can take to reach the bottom right. So starting from 00 till m minus 1 n minus 1 position, there will be how many paths that the robot can take. So that will be our idea over here. Fine. So we need to find that out, like how many paths are there. How paths, what do you mean? Say the robot is at this position. Okay, at this position, and there's like 2 cross 2 grid. Let's minimize this to 2 cross 2 grid. Okay, so robot is at this position. So in that way, the one path will be going right and then going down. Fine, and reaching the finished version. The next path will be first going down, then going right. Fine. So that will be the two paths will be there. So if it's a 2 cross 2 matrix or the grid of 2 cross 2 given to us, then that will be the two paths available to us. Okay, so there we can understand. Now it says like the test cases are generated so that the answer will be less than or equal to 20 to the 1 and fine. So that's the limits are given to us. Fine. Let's try to break this problem. Okay, let's try to break this problem and understand how exactly the question is asking us to do and how exactly we can go ahead and find a solution to this. Fine. So in this, say we have a only 2 cross 1 grid. Fine. This is a whole grid we have over here. Fine. So now how many ways, like starting from, let's say like initially, let's take there's only one grid, like 1 cross 1 box is there. Okay, so how many ways we can find a solution to like reaching the end version? There will be zero ways, right? How many ways? There will be zero ways, because once we are at the end position, how many ways we need to reach the end position? Zero ways. Do we need any way to reach the end position? No. So if we are at the finished position, we are in some of the phase position, so there will be zero ways to reach the finished position. Like that's at the 1 cross 1 box. Now let's say 1 cross 2 box. We are at this position. Our robot is at this position, and robot wants to reach the finished position. So how many way robot can take? The robot can only take a right move, a single right move, and the robot will be at its finished position. Right. So there will be only one way. Now consider the same thing. If it's a 2 cross 1 matrix, okay, only this part is there. Fine. So in that case, how many ways a robot is at this position, and the robot wants to reach the finish? So how many ways it can reach the finish? It will have only one way, isn't it? It can only move down a single unit, and it is like done with its it reaches its finished position. We cannot move right because we will be going out of the grid. So that will be only one way. Now See, if it was a 2 cross 2 matrix, fine. If it's a 2 cross 2 matrix like this, now our robot is standing at this position, fine, at this box, at this white box, and it wants to reach the finish. So our robot can take a right turn, or a robot can take a bottom turn, like a down turn, fine, either right or a down. So if it takes a right, so from this right, how many ways we can reach the finish? There will be one way. If it takes a down, how many way we can reach the finish? There will be one. So how many way we can reach the finish from starting from this position? It will be the two ways. Fine. I think it's understandable that if we take a right turn first, okay, then we know there is one way to reach the bottom. So we know that from this position, right turn one way. If we take a bottom turn first, then we know there will be one way. So the total how many ways are there? Total two ways are there. Fine. Now look at this, if we're at this position, right, at this white box, how many way we can reach? We cannot go down, okay, well, because down is going out of the box, and we can go only right. So if we go only right, so then look, if we're going only right, then how many we can reach the finish from this particular box? Is one. So from our current box we can reach to a finish in a single path. There isn't multiple paths to go, right? There's only single path that is going from here to here. That's a single path. Now the similar thing goes for this particular box, this particular corner box. Okay, if I add this box and we need to reach the finish, then how many path you can see? Can we go right? No, we can go only down. Fine. From our down box, that the current box, the new current box, how many way we can reach finish? That's the one way. So how many way we can actually reach finish? It's like one way from our current this particular box. Fine. Now in a similar way, look, for all the boxes on this line, okay, on the like final line, how many ways we can reach finish from this particular box? There will be only one way, because we can go only right, and the right box, from right box there's only one way to go to the finish. Okay, we know it previously. Now from a box like this, we can go only to the right, and from the right box on the right, we have only one way to go to the finish. So we know that there will be only one way to go to the finish. Similar way, now look, all the boxes over here will be on the bottommost row. We will find that there will be only one way to reach the finish, because we cannot go down. We have only to move the right, and we cannot move up, or we cannot move left. So it's like there's only one way to reach the finish. Now the complexity comes from here. You can understand better from this question. Okay, say we are at this particular box, okay, at this particular box, at this grayish box, and from this box we can take a right. Fine. If we take a right first, then we know there are two ways to reach the finish. Fine. And if we take a down first, we know there's one way to reach the finish. So how many ways total, how many ways we can take to reach the finish? It will be three in the sense, if we take a right, there are two ways. If we take a down, there are one way. So we are going back, well, like we are backtracking, or you can say we are just keeping a note of all the data we have previously found, like more of a DP kind of concept. Okay, so that's what we're trying to do, and we're trying to find out the ultimate result in the same way. Let's go ahead further. From this particular box, how many ways we can reach the finish? If we could take a right, we know there will be three ways. Okay, so it will be like, if we take a right, there will be three ways. If we take a down, there will be one way to reach the finish. So how many is the total number of ways to reach the finish? It will be like four ways to reach the finish. Similar ways, it will be like five ways to reach the finish. If we take a right, there will be four ways, and if we take a down, there will be one way. So 1 plus 4, there will be 5 ways to reach the finish. Similarly, you can see there will be 6 ways, and there will be 7 ways to reach the finish. Fine. Let's go further. Let's go ahead. We find that if you're at this position, okay, we will have similarly three ways to reach the finish. If we take a down, there will be two ways. If we take a right, there will be one way. So 1 plus 2 is 3. Similar way, we just keep filling the boxes. There will be 6, there will be 10, there will be 15, and similar way, you can see 15 plus 6 will be 21, and ultimately 21 plus 7 will be 28. So when you find 28 being the total number of ways we need to reach from 0, 0 till m minus 1, n minus 1. And see, that's our ultimate answer is. So that's how our exact concept behind this question works. Okay, so that's how we actually reach to the end of the like find a solution to the whole concept. Okay, similarly if it's like m is 3, n is 2, see it's like 3 comma 2. Okay, that's this part of the box is only asked in our second example, and the answer is 3, because see we found the answer is 3 as over here as well. So it's just you are trying to find out all the possible ways in this type of question. Fine. So I hope I can make you understand like what is the basic concept behind finding a solution like this, or what will be the thought process there in finding a solution to this. Let's go ahead and write some code over here. Complete this code based on the exact concept that we came across over here. Fine. Let's do that, and then let's find this out. Fine. And that's you can find that this is a 1ms solution. So it varies somehow between 1ms and 0ms based on various other stuff. But yeah, it's a more or less 1ms 0ms solution. Let's try to see what exactly we did. We first took a grid of mn. Why do we took a grid of mn? So that we can go ahead and like we had this only m cross n mn given to us, so we just created a grid for us. Okay, further we just started from our this last position. Okay, at this finished position, the way we are doing in our example, and yeah, and we started from this last position. And what exactly we did, we went ahead with like you can see, so we went ahead with the reverse loop from m minus 1 to 0, and similarly from n minus 1 till 0. So that's the way we went ahead with it. Further, we just keep the check if it's the I is m minus 1 and j is m n minus 1. So if we're at the corner rows or the corner columns, our value will be 1. So that's what we just did over here. Fine. So that's the whole thing we did over here. And else, what we did, we just made a summation of this. If we had a box at this position, so we made a summation of I plus 1 and similarly j plus 1. Okay. Sorry, I just said the reverse way. I just made a summation of I plus 1, that's the down one, and the j plus 1, that's the right one. Fine. So that's the I plus 1 grid of I plus 1 j and grid of I j plus 1. Fine. So that's the both thing we did, and ultimately we just returned a grid 0 0. See, we just found the answer to this at grid 0 0. That's the exact way we just found it out, right? Right. So that's what we returned over here. So you can see that in the submissions, it just took us 1ms as a solution, the time period to find the solution to this. So that's more or less about this question is all about. I hope I can make you understand how this question works and how you should approach a question like this. So thank you all for watching this video. I hope I can make you understand. Make sure to subscribe to this channel for regular LeetCode videos like this. Also like this video and share it with your friends who are solving today's LeetCode problem. That's a unique pass. Okay. I hope this will be helpful for them as well. So thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.